So we have composable building basically two chains, or already having two chains, which are substrate build parachains. One is on Kusama called Picasso, and the other one on Polkadot. And you guys are implementing CosmWasm on there, which is the first time. I remember we had this interview at your Unchained conference in Berlin with Ethan Frey, the godfather of CosmWasm. And he was so excited. Like, he was like smiling all day because he's like, that's the first time CosmWasm is going outside of Cosmos. So you are a substrate chain implementing CosmWasm and also becoming IBC compatible, which will enable full compatibility between the substrate world and the Cosmos world. I think that's really, really cool. But I think for a lot of people, it's a bit hard to like understand all these different elements. And you sent me a little graphics, which I'm trying to share right now. And then you can walk us through basically how all these pieces fit together. Basically explain a little bit, and then you can walk us through how the architecture works of Pablo, Kusama,
Sure.
Polkadot, Picasso. So basically you have XCVM, which is this interoperability standard that you guys are developing. You have Centauri, which is an expansion of IBC. Then you have Picasso, which is the parachain on Kusama, and you have Composable, which is a chain on Polkadot, right? So can you explain how that all fits together?
Yeah.
And also it's like Pablo as a DEX, where this is going to launch and how this all plays out.
Yeah. So first of all, like, we should put the Polkadot parachain aside for a second, because everything comes, the way it works in Polkadot is everything deploys on Kusama first, and then after sufficient testing and being in production for a long time, it moves up to Polkadot. So because we're in like early launch phases, everything is happening on Picasso. So that's the first thing. So first you have Picasso. What Picasso is made up of is a series of runtime modules, just like in Cosmos SDK, you have modules, same thing in Polkadot. One of those is called Pablo, which is XY equals K DEX, stable swap. We also are working on UniV3. So all the nice features of a DEX you would expect, liquidity providing, staking LP tokens, emissions, those are all sort of going to be packaged into Pablo. And Pablo is going to be split up across two releases. The first one is in mid-December, where we just get the DEX out with some initial pools. And then early January, things go permissionless. People can start staking for emissions, and there will also be just various different LP opportunities as well. What powers the Picasso chain is Pika, the Pika token. The Pika token will officially TGE when the Pablo DEX comes out. Pika is used for, paying for gas, securing the chain as well, using collators. Also like paying for various fees, like to trade and things like that. So it's a very similar token model to, like, I would say, Juno and also Osmosis. And you can find more about that on our documentation. Pika will be able to be staked for X Pika, which gives you a share of revenue, fees, voting power, etc. And you can then stake those X Pikas with collators to start making this APY, like normal proof of stake, basically. Now, on top of all of this, that's where we have all the IBC stuff. So we have the KSM dot bridge, we have the bridges to different Cosmos chains, and we have NEAR. All of that is called Centauri, and this is, like, we call it ecosystem agnostic IBC. So we've extended the IBC protocol itself to become ecosystem and Cosmos specifically agnostic. Now, if a user wants to trade something on Pablo, but has a Kepler wallet and starts on Osmosis or something, say there's not enough liquidity for dot atom on Osmosis and they need to do that on Pablo, this is where XCVM comes in. So a user can just connect their Kepler, specify that they want to make a trade of .atom on Pablo, sign that transaction, and what happens is a series of IBC messages occur. So first you bridge, then you swap on Pablo, then you bridge back. And all that gets done from signing a single payload. So XCVM is kind of this like messaging layer on top of IBC that allows for this type of like high level orchestration. Now this then unlocks a lot of really cool stuff. So, you know, think of all the things that people were excited about with the interchain accounts. Now this can be written as an actual contract, and you create an entire application around an interchain accounts like system. So just as an example, right, like let's just say we want to open up options positions on say and DYDX. Normally you'd have to go to each chain and make 2 different accounts and then maintain your collateral on both chains. But what if you could have one account, right? That's where XCVM comes in. You deposit your funds into one contract, and then this can get propagated to different chains. And if for some reason you're getting liquidated, this then happens in a single location, not multiple different locations. So I think it's not really clear what interesting cross-chain use cases people will build with XCVM. We're going to be putting out a bunch of examples like cross-chain liquid staking, like this Lido proposal we put out with Neutron. But it's safe to assume that we'll be able to do XCVM activities on all the Cosmos chains we're interested in connecting to. So that's also really exciting, because the same way that an Osmosis user can trade on Pablo, it's also the same vice versa. So if a Picasso user has just a Polkadot.js wallet and they want to trade on Osmosis, they sign a transaction and the swap is done on Osmosis, funds are bridged back. So yeah.
So basically in the future, like any Cosmos chain could also implement XCVM.
That's right. Yeah, that's right. All they need to do is just deploy.
No, yeah, go ahead. Deploy what?
They just need to deploy a set of contracts. They're called interpreter contracts that basically just interpret the messages that are getting passed. And that's it, basically.
Yeah.